Hi everyone, in this video tutorial we will cover the advanced measurement features and general advanced features of the Vision software. Anything we haven't covered yet in the previous video tutorials will also be covered, so you'll have a full overview of all the features and what they do, and hopefully this will lead us into the next examples and help you measure any of your components going forward. We'll start the tutorial by working our way through the features that weren't previously covered in the basic video. The first one of these is the point feature. We select point, and the idea is rather than measuring features as circles or lines, if you just want a peak height or something like this, you can click on the edge and the software will define the intersection between your scan line and the edge of the feature. It's useful in circumstances where you want a length to a point rather than line to line. So to give you an example, we can get the length this way, and it's a more simple measurement than trying to measure line to line. The next feature is peak point. It works similar to the point feature, only instead of defining the edge, we define a scan area with 2 clicks. 1, 2, set the scanning window, and the software will pick up the peak point from a given edge in the scan area. It results in a point in the software as normal, and that is peak point. The next feature we'll cover is the thread feature. Select the thread, and to define the scan we take a point at the beginning, so left click here, one left click at the end, move the mouse up or down to set the scanning window, and then left click again to initiate the scan. The feature itself is a curve within the standard software, but it does house some important details. If we go to the drop down arrow for the display window settings and choose information, we can now see the thread summary. We get the pitch, this is the highest, average and lowest. The same for the thread angle, so this is the flank angle, useful for working out what type of thread, whether it's a 60 or a 55, etc. And we can now come back out of here and hit the green tick. So that is a curve within the Aberlink software. If we measure the bottom thread, we'll get the same idea. So it's 2 separate curves, and we can also do some useful constructions from the curve thread measurement. So if we construct a line, construct and select the curve, we can now have an effective diameter, minor diameter or major diameter. The software itself doesn't know whether this is an outside or inside thread, but don't worry, if you select the wrong option, you can always cycle the construct button to give you your different options. So we'll do the same again on the bottom thread. Choose effective. If it's not the one you want, you can cycle through, and this would give us the outer diameter. We can do the same for the effective and the minor diameter if required. And that is the thread measurement. The next feature we'll cover is the curve feature. Curve. This works slightly differently to the other features. We'll start with the small profile in the middle. We select the edge of the feature we wish to scan. We then move the mouse 90 degrees to the edge we've just selected, or perpendicular. The distance we move the mouse is the scanning window. Once you are happy with the scanning window, you can left click. An arrow then follows your mouse. This is defining the direction that the scan will head in. So we'll select here. And then finally we have a crosshairs to define the scan end. So if we wanted to scan all the way around this profile and come back to the start, we would click roughly here. And then the software automatically executes the scan. and you'll see it shows up as a curve feature within Ablink 3D. Let's repeat that again for the larger inside profile. So again, we're already in scan mode here for curve. So we click on the edge, we move our mouse to set a scanning window, we tell it the direction we want to head in, and then we tell it where we want the scan to end. And there we go, it executes the command. If I right click and redraw, you'll see that profile there. The software can actually move around if the edge goes outside of the field of view. So I have deliberately moved this outside profile so the edges are outside the field of view. So you'll see it in action here. If I select here, scan window, head in this direction with a left click and end here, the camera actually moves to execute the command. And the data shows up exactly the same as before. The curve feature is useful for scanning things bigger than the field of view, or if you need a free-form surface to follow. And it is also useful to note you can construct things from the curve data itself. So for example, we can go line, spanner, and I can click and drag a box around these features, and you'll see this is now a line that I can reference. Same with circle, so circle, construct. I can either drag a box around it or I can hand pick points by left clicking. And there is a fully fledged circle inside that we can dimension or use as a reference, etc. So this is the curve function. It's worth noting the curve is mostly used for doing profiles and a DXF comparison. This will be included in one of the example parts at the end of this tutorial series. So keep an eye out or skip ahead if you are looking to do DXF comparison to a curve scan. The next feature we'll cover is the one-click feature. This is the feature where you say, David, why didn't you show me this at the very beginning? Because it is incredibly useful. So when you select it, the idea is you click on the edge of the feature and the software will auto-define what feature it is and when to stop the edge. It deliberately doesn't go too close to the edge, also for future programs in case the part moves very slightly. But the idea is we can just go around single clicking on each feature and the software picks it up automatically. Again, we just hover over the edge, left click, and the software will start scanning the edge. And you see they're just standard features in the software that can be referenced or dimensioned just like anything else. So it's a very useful feature, and that is one-click feature. The next two features I'm going to cover work in a similar way, so will be housed within the same part of this video. They are all edge points and all features in an area. We'll start with all features in an area, and the idea is we do two left clicks to create a box around the edges of the things we want to measure, and the software will automatically detect and pick up on all the features within that box. This one is more commonly used as these are actually individual features, i.e. circles, all separate features within the program. So this is all features in an area. If you want to use all edge points, you have a similar situation. I'll just start a new inspection. But it works using a curve function rather than individual features. So all edge points, define your box around the features, and then the software picks it all up. Only it's a curve, so it's good for DXF comparison and things like this. But if you actually want to know the sizes of the individual features, it's better to use all features in an area. So that is all edge points and all features in an area. Finally, we will cover the ruler feature. This is a manual measurement. So if we switch to ruler, the idea is we click 2 points and the software then gives us the coordinates and the distances. This is only a manual measurement. It can't be written into a program as it does not measure any features. It's just for quick manual measurement. This is the ruler function. We will now cover the different inspection methods. For all the previous exercises, we have been using edge detection. This is the most common application with vision, but also useful is center detection. So center detection is good when you want to measure the center of a line given 2 edges rather than the edges themselves. In this example on the graticule, you can see a circuit board example, and this is useful where you want to know the center line of each pad and the track rather than the edges themselves. It works the same, so we set a scanning line and a window, and the software will look at both edges and create a midline. Just another example. Measure the line as normal, set the scanning window, but the software will track both the center lines rather than the midline. It's also useful if you're measuring, say, the ruler on the bottom. It is the middle of the line where the measurement comes from. So we have to use center detection rather than edge detection to get a good measurement of the center of the line. And that is the center line detection. Start a new inspection and we'll cover the remaining ones. Vision and escape. There we go, and we'll start from scratch. We also have a crosshairs option. This uses the crosshairs in the camera window itself, and this will literally just take points wherever the crosshairs are. One click on the screen registers the point, and this is good just for quick manual measurement, but it's nowhere near as precise as edge detection. You'll also notice while we're on this topic, when you are using crosshairs or mouse points, show edges automatically switches on to give you the target of where you've actually taken the point. So this is crosshairs, again only good for manual measurement. It's not as precise as edge detection, but it's a useful tool if you need it. Start a new inspection again. We'll then move on to mouse point. This is exactly the same as the crosshairs, only you have a little bit more freedom, as you can move the mouse more freely than you can move the crosshairs of the camera. So again, this is mouse point, and it works for all features. So if we say a line, and it's just taking our mouse points, and again, not as accurate as the edge detection, but good for a manual measurement if it's required. If you need a little bit more precision on this, there is now also smart mouse. This works exactly the same as the mouse point, only if you need to run the program back, it will give you a turquoise circle as a target zone to take the points. So let's give this a go with a new inspection. So if I create a program with, let's say, a circle on the 8mm using the smart mouse, because I'm struggling, or the camera is struggling to pick up on the edge, but I feel I can visually see it better, I will touch the points manually, switch to a line, and again I'm using my eyes to set the points rather than edge detection, and it works for all the features. So if I say arc, I can go here, here, and here. And if this was being used as a program, And again, just to stress the point, this is used when the camera struggles to get the edge of the component, but you can visually see it by eye. You can use Smart Mouse to create a repeatable program, picking up on the edges by eye rather than using the edge detection. And the reason we use Smart Mouse is if we play this program back, the software drives over and gives us a target point to try and measure. So it has to be within this window. There we go. There we go. And then I drive over. There we go. It automatically moves over to the next feature. And again, I'm just picking the edge by eye and selecting it by hand. And the circle is the target area of where the point should be taken. Click, click, and click. And there we go, that updates itself. And you see it's pretty repeatable, but again it is a manual measurement method, Smart Mouse. And it's not as precise as using edge detection or center detection, but it is one of the only options if the edge detection isn't working because of a bad image, or the camera is struggling to break up on the edge. So it is a manual option and it's useful for certain applications. The last inspection method we are going to cover is the focus point option. To have this available, we need to make sure point is selected within the feature drop-down list. And the idea behind focus point is we use the camera to focus in on the surface of the material or component we are measuring. Once the focus is perfect or as good as possible, it will log a point from the Z-axis. We can then change height to a different surface using the focus again to register a point, and this will give us a 3D Z height measurement. So it does give us some level of 3D functionality, even though it is typically a 2D XY measurement system. I'm using this example now, this small V block, or sometimes referred to as a butterfly block. And the idea is we're going to focus in on the top surface, then focus in on the bottom of the groove. The height differential when measured on a CMM is 3.2 millimeters. So we can have a look to see how close we can get with the camera using the focus point. The idea is we use the joystick to manually drive over to the surface we wish to try and get the focus point on. And we will try and get as best focus as we can manually. We then, with the two features selected, we click a point on the surface, we move the mouse down and to the right, and this sets a window for scanning. The bigger the better, because it gives the software more surface to focus in on. And the second left click defines the scan and tells it to start. The vision software is now going to move the camera up and down slowly, looking to get the best focus on the surface as possible. And when it's happy, as it was there, it registers a point. If we now move over to the middle of the groove, and again we need to use this manually to try and get as close as possible by eye. So something like this. Again, we click a point, we move down as much as we can, and then to the edges, click again. That will initiate the autofocus. And again, when the software has analysed and got the focus as good as possible, it will register a point, write that into the software, and we can get the height differential from the 2 points. So there we go. So there's our 2 points, and if we dimension between them, set it to vertical, you'll see it's 3.208, so 8 microns away from the touch probe on the CMM. And you'll see it now gives accurate Z readings without the need for the touch probe. And that is the focus point. A useful feature along the toolbar that we haven't covered yet is the save image function. This is great when you have a defect on a part that you need to highlight to a customer or supplier. You can use the camera to take the image. You have camera image, current view, or metrology image. Camera image is the most common, and it will ask you to save the image as a JPEG or a BMP file, which you can then use to send to the customer or supplier. You can modify it, but it highlights things like this rust mark or dents and swarf and things like this, so it is very useful. So we are back to using the Graticule now, and I want to cover this feature here, scan area. So the idea is, as mentioned in a previous exercise, with overlays, recent images, if we have toggle overlay and remember recent images ticked, we can use the machine to scan a set area to get the entire component or part on the screen, so we can pick larger measurements off rather than just using the standard field of view. In this particular case, if we zoom out and then select scan area, we can left click where we are and then move the mouse up and out to set predefined scans, and with the final left click the camera will then execute those scans by moving through each section of the box we created. It will pause, log the image and save it on the screen. And you can see it's going to systematically work through the different boxes. And the idea is, once the camera has built up this entire image, we can actually now create dimensions or scans outside of the standard single field of view. This is really useful for bigger components, or if you simply want a bigger image of the thing you're trying to measure if it does not fit within the standard field of view. I will cover an example of measuring with this feature in the second part example. So we're not actually going to use any measurements here, but it's just to show you the functionality of how the scan area works. Now the scan area is complete, we can move on to the next feature I'd like to cover, and this is buffer tools. Buffer tools, when selected, allows you to delay measurements, so you can stack up your measurements in a queue, and when you're finished the camera goes and executes all the measurement commands in one single go. So we have it switched on now. We'll go to edge detection and let's just say circle, and we'll pick off some of these circles, and you see it doesn't actually measure that. It's waiting for me to continue selecting the features I want to measure, all in one single command. You can go line, and then when we click buffer, the camera moves over and executes the commands that we just asked it to do. So you can think of the buffer tools feature like a log or a queue, and we put all the measurement features into a queue, and then when we tick it off, it goes and executes that list or queue of feature commands. So that is buffer tools. The last thing I want to cover in this video tutorial is the camera setup icon and vision setup. Generally speaking, with both of these, it's best to leave the settings to default, or in this particular case with camera setup to auto. This will allow the software to do all the adjustments itself. I wouldn't recommend messing around with these, but if you do and you have a problem, you can just go back to auto. The same applies for the vision software. I would just use default. I don't recommend messing around with any of these, but if you do want to mess around with them, you can see the effects when you're measuring, and if you have any issues, just click default and it will go back. That concludes the video tutorial for the advanced features. There will be following videos that cover real-world examples, putting together all of the different features and skills we've learned in the last two video tutorials. So please watch them to see some real-world examples of using the camera and vision software. But that concludes the advanced video tutorial.